Hi everyone, today I will show you TaskingAI, a game-changing platform in the world of AI native app development. The current landscape is often characterized by the challenges of handling different API integrations of different LLMs and integrating different data sources. This is where TaskingAI makes a significant impact. It simplifies these challenges with its unified API interface, which allows for seamless access to a variety of AI models. This integration streamlines the process significantly, removing the complexities usually associated with handling multiple systems. Additionally, TaskingAI efficiently manages various data sources and vector stores, a task that is used to be cumbersome. By reducing complexity and enhancing efficiency in integrating and managing different AI components, TaskingAI revolutionizes the approach to developing AI-native applications. I will walk you through the TaskingAI platform and show you its capabilities. You will learn how to create models, create assistants, integrate data and tools into your assistant, and use the Python SDK to use an assistant in a full-stack application with fast API. We will create an app that allows you to switch to a different model and data source in production by just changing a simple environment variable. The first step is to navigate to tasking.ai. Here you will find their website with information about their product, and you can read about the concepts that I will show you in this video. You can go to the developer docs, and they even provide a forum for their users. To create an account, just click on Get Started, and there you can create an account with your first name, last name, and so on, but you can also take the happy path with just signing in with Google or your GitHub account. After creating an account, just click on Sign In, and then here, after signing in, you will find this user interface. Now it's time to create our first project. Just click on the New Project button and call it whatever you want. My first project, and here AI development or so on. The host type is serverless. This is currently the only option. Then click on Confirm and then click on the project. And now here you can see you can create a model, you can create assistants, retrieval tools, and so on. I will walk you through every step. First, let's create a new model. Just click on the new model, and here you can see the different supported model providers. We've got OpenAI, Anthropic, Google Gemini, Mistral, AWS Bedrock, and many more. So I will pick an OpenAI model in the first step, and here just click on that, and now you can select the model you want. I will pick GPT 3.5 Turbo since it's a very cheap one, but still performant enough for most of the tasks I want. So now we can create a model name, and I will just set it to OpenAI model, and here we have to provide the OpenAI API key. Copy your key from OpenAI and just paste it here. Then click on Confirm, and now we've got a model ready to use. What's really cool about TaskingAI is that they provide a playground like the OpenAI playground, but for every model provider. So just click here, and here on the top we've got the option for chat completion and assistant. Since we did not create an assistant yet, we cannot use that, but currently we can select chat completion and test our model. Just pick your model here, click on Confirm, and now we've got this nice chat interface. On the left we can configure our model, like if we want the response as a stream. We can also change the temperature of our model, we can enter stop sequences, and so on. On the top we can now create a conversation. The system message defines the behavior of our bot. So let's say, always be very funny when you answer, and then the LLM will try to be funny. And then as user message we can just add hello. We can also add another message like assistant. So this is a fake answer of our model, but yeah, currently we don't want that. So just try that. And here we can now see the response. Greetings human, how may I humorously assist you today? Great, so we can see that this works in the playground. So let's now create our first assistant. An assistant is a solution which adds tool invocation, knowledge retrieval, and context management capabilities to an LLM. So let's create our first assistant. Click on the button, and then let's name this first assistant. You can also provide a description, but this is not mandatory. And now we have to select a language model for our assistant. We only have got a single one, so we will select this one. And now we can define a system prompt like before. So be very funny when you answer. We also want to select one of the three memory types. So the memory is the assistant's ability to retain and use information from previous interactions. We've got 3 different types. 0 means no memory at all. So this is used for interactions where no contextual memory is needed. Then we've got message window and naive. Naive is suited for conversations that require full memory recall of the entire session. The message window is designed for dialogues that need context from recent messages while avoiding irrelevant information. So if our conversation exceeds, in this example, 20 messages or 2000 tokens, then the LLM will create a summary of our conversation. We can also integrate retrieval and tools, but I'm gonna show you that later. So let's first create our assistant without that. Let's now click on confirm, and again we can go to the playground and now select an assistant. So let's pick that assistant, and now we can create a new chat. And here, instead of manually creating system messages, user messages and AI messages, we just have this simple chat window. So let's ask, what is the capital of France? And we can see that the capital of France is Paris. So great, this works, but now let's assume we've got a restaurant called Bella Vista and we want to provide that assistant the knowledge about our opening hours. So if we ask, what are the opening hours of Bella Vista, we of course don't get an answer since the bot does not know about Bella Vista. This is where we have to integrate retrieval in our assistant. Retrieval means that the assistant has access to knowledge which was not trained into the model. So let's create a new collection in retrieval. Click on new collection, and now we can call it like opening hours or whatever you want. And here we have to set an embedding model. Embedding models are models that create large vectors which capture the semantic meaning of text. These vectors are then used to compare questions from users to our data. The most similar data will then be retrieved and sent as context to the LLM. And this is why we have to set a model in this step. OpenAI has got multiple embedding models, and here we can see that we can pick from 5 models. So we will pick a small and cheap one. So this is the cheapest model from OpenAI, the text embedding 3 small model. Let's confirm that. And now again, we have to provide our OpenAI API key. Let's paste it here and call the model embedding model. Confirm that again, just pick it and then click on confirm. And now confirm that. And now we got our first collection. So currently this collection is empty. We can see we don't have any records in that. So to create a new record, click here on the right on record, and then here on new record. And here we can call that opening hours. We can pick from 3 different types: text, website, and file. So if we want text, we can just enter or paste the text here. If we want a file, we can just drag and drop the files here. And what's really cool is that we can also provide a link to a URL, and this whole URL will then be indexed. But we will just paste text. You can also find the text in my description. So what we're going to do here is we paste this text, and we will not index this whole text. As we can see, we've got 3,407 characters. So the default way is not to index the whole document, but to split the document into smaller chunks. And this is what TaskingAI provides. Smaller chunks make it easier to capture the semantic meaning in a vector. So we normally split that, and we can set a chunk size and also a chunk overlap. And I will just set the chunk to 150. And then let's confirm that. So let's now close that. And if we press F5, we can see that now we've got 1 record. And the record was the original document we added. And we also can see that we've created multiple chunks from that original document. So we can create the record, we can also delete or update individual chunks. So pretty nice. Everything can be done in this user interface. The next step is to create that retrieval to our assistant. So let's go back to our assistant, click on edit, and now we want to select a collection. So let's select that. And now we can set the retrieval configs. So in the method we set if we want to use a function call to retrieve the information, or which is the normal way, use the first user message, or we can use the complete memory for retrieving the information. Then we get top K chunks back from this collection. We can set how many documents we want. We can say we want 4. I think 4 is the default for most vector stores in frameworks like LangChain, for example. So let's confirm that. And now let's go back to our background. Let's select our assistant again. And now we just continue with that conversation. So let's try that again. When are the opening hours? And as you can see, now it uses retrieval. And we can see the response from our assistant is that from Monday to Thursday, these are the opening hours, and from Friday to Saturday, these are the opening hours. So this works too. We have got one more option to integrate in our assistant, and that is the option to add a tool. We can do this by selecting a plugin, click on New Bundle, and here we can see all of the available plugins. So we've got Alpha Vintage, which is for stock data. We've got DuckDuckGo, DALL-E 3, Google Search, and what I will pick is DALL-E 3. So before we do that, let's just go back to the playground again and ask, create an image of the restaurant Bella Vista. So let's try that. And now we can see that it uses retrieval, but it's not able to create images yet. And this is why we need a plugin. This is done by clicking on Tools, and we can add a new plugin. We can do it this way by just editing and then do it like this. So we can also do it here. Does not really matter. I will show you the way here. So let's go back and go to Tools, add this new plugin, and here you can see it is the same interface like before. So we add DALL-E 3, and now we're gonna confirm that. And again, we need our OpenAI API key. So let's confirm that. And now go back to the assistant, edit the assistant, and here now we add this DALL-E 3 image generation plugin. Let's confirm that. Let's confirm it here. On the playground, just click on New Chat, and here we now want an image of a dog. So let's ask that. And now we can see we are in chat completion, and the tool we just integrated is now used. This may take a few seconds because we make a request to the DALL-E 3 API. And here we can see the result is streamed back. In the playground, we don't see an image. We only see the link. So this will be maybe added in the future. But you can, of course, just copy the link and paste it in the browser. And here we can see this is the result of the DALL-E 3 API. Here is our dog, and the image is stored in a blob storage of OpenAI in the cloud. Okay, so far we only used the user interface to interact with TaskingAI, but we can also do that with the Python SDK, which makes creating assistants even easier. Okay, I'm now in Visual Studio Code, and here you can see multiple files. First, we're gonna walk through the code IPython notebook to create an assistant with the Python SDK. And before we do that, we have to install the package with pip install and then TaskingAI. This will install everything, and now we can use the Python SDK. So the first step is to load our environment variables, which are stored in the .env file. So to do that, we also have to install python.env. This makes everything easier. And here we can see these are our variables. We've got a TaskingAI API key. Then we've got the OpenAI API key and assistant IDs. So these don't exist yet, but this is what we're gonna create now. To create an API key, we have to navigate in the user interface here on the left to API keys, and then click on New API key. Here we just type in a name which we want. Let's confirm that, and now we've got our API key. So we can see the API key here on this I button, copy it, and then just paste it in our .env file. So we place this API key here, and now we've got a valid API key. Okay, so let's import our environment variables and then initialize TaskingAI. Now we want to create an assistant. As you remember, an assistant can have retrieval, can have tools, and uses one specific model. So this is what we're gonna create. So we create for retrieval first a collection, but this time not in the user interface, but here in the Jupyter notebook. So we call it my SDK collection, since we create this with the SDK. For creating a collection, we need an embedding model. And here as argument, we've got the embedding model ID. So we have to provide this ID. So the ID can be seen here. Just go to models, and here we've got our OpenAI model and the embedding model. Just click here. This copies the ID and just paste it here. Now we can create a new collection. So let's execute that code. And what we're going to do now is we want to put data in this empty collection. To do that, we have to insert a record inside our collection and also create chunks. So from the original document, we do that with a text splitter, and we provide a chunk size and a chunk overlap, like in the UI before. As content, we provide a simple text here, so we don't actually need that splitter, but for demonstration purposes, let's just execute it like this. Of course, we have to import this first. Let's execute it again. And now we created a record and chunks from that. We also saved this as metadata. So let's say we extracted that information from a file called machinelearning.pdf. Let's now navigate back to the UI, press F5, and now we can see we've got this SDK collection. We've got chunks, which is a single one. And we also got this record. We can directly edit this in the UI too, but yeah, that's how it works with the SDK. So now let's create an assistant from that. So the first step is to create the assistant with a model ID and give it a name. So we call it my SDK assistant. And for the retrieval, we want an assistant retrieval, which is a class which we import here. And we set the type to collection. This is currently the only type supported, but I guess since this is in enum, in the future more different assistant retrieval types will be supported. We also provide the ID from that collection, and this collection which we created here has got this ID attribute which we can use directly to pass it here, so we don't have to go in the UI to extract that information. But for the model we actually have to, and I want to show you how we can use a different model. So I don't only want to use the OpenAI model, but I want to use an entropic model. So I've got an entropic API key, and if you've got this too, you can also use an API key from there. And if you've only got OpenAI API keys, then you can also create a second model from OpenAI. So I just call this entropic model and paste my entropic API key here. Then just click on confirm. And now we've got a new model, which is from entropic, and this got the following ID. So let's just copy that and pass it here to create a new assistant. We also have to provide a memory class, which was assistant 0 memory, assistant naive memory, or assistant message window memory. I showed you the differences in the UI. So let's use assistant naive memory because we actually want to store the conversation in a memory. Okay, and now we can use our assistant to create a chat. To do this, we have to use the create chat function from the assistant module of TaskingAI and pass in the assistant ID. The assistant ID is stored in the attribute of the assistant, which we created here. And now when we've got a chat, we can use the create message function also in the assistant module, and we pass in the assistant ID. And we also pass in the chat ID, which was also created by here setting this up. So we've got the chat ID, the assistant ID, and now we can pass a text. This is the question which we want to ask. So now let's run this. And now we can see this created a message object with an ID, the chat ID, and the assistant ID. The role is also user because this is a user question. And now we want to generate an answer. So nothing happened here yet. We only created the message. To interact with the LLM, we have to call the generate message function. This is why it's called generate, because this actually interacts with the LLM while we only create the message here. So this will create the assistant message. We also pass the assistant ID and the chat ID. So the real answer text is stored here in the content and then in the text attribute. The assistant now says to the question, in which country is Paris? Paris is the capital and most populous city of France. So if you run it again, very important, this does not work. We only or always have to create a new message and then generate an answer, because we always need a user message and then an AI message, user message and AI message, always in that pattern. So let's now do this. So we create a new message, and this is a follow-up question. And the question is what to eat there. And this word there only makes sense if the model or the assistant knows that before we asked what is the capital of France. Otherwise, this would not make sense. So we check if the complete history is stored. So let's do this and create the message and generate the answer. And now we should get an answer which takes our first question into consideration when answering this. And as you can see, the assistant is aware of that. Here are some top foods to try when visiting Paris. Okay, now it's time to move from a notebook to a real-world application where TaskingAI even shines more. With just a single environment variable, we will now change the assistant and therefore change the model and also the data source. This makes development and deployment of generative AI backends very easy. So everything is done in the app.py, and what we're going to do here is we're going to use FastAPI to create a real backend and integrate TaskingAI into that backend. So the first step is to import some libraries like the assistant from TaskingAI. We also import the FastAPI class from the FastAPI library, and also like the file response, because we also have got a little demonstration front end. The next step is to set up logging so we can see what we actually use in the code. This makes debugging and so on very easy. And then we load the environment variables from our .env file. After that, we create new variables from our environment variables like the TaskingAPI API key, OpenAI API key, and so on. We also set the assistant ID 1 and the assistant ID 2 because we will create a fallback mechanism. If our assistant 1 fails, then we will use the assistant ID 2. But we will only do that if we set fallback to true. So we can toggle that on and off. And then the next step is to create our app. So this is our FastAPI backend. And in our FastAPI backend, we will store also sessions, because as we've seen before, when we create a message and generate a message, this will be stored in memory. So in this case, we've got a stateful application. So this is why we also store the sessions here in this variable. So this is not a RESTful API, but it's a stateful API. The next step is to create a function called getAssistant, where we only return the assistant module from TaskingAI. This is because we use dependency injection in FastAPI. So we inject that directly into another function. And now we create the actual chat logic. So we create a base class which has got an async def called chat, where we pass in an assistant, a user ID, and a user message. And currently it's not implemented. So we have to inherit from that chat logic. And the subclass actually has to implement that method. The next method is a private method called chatLogic, and here we pass in the TaskingAI assistant, we pass in an assistant ID, a user ID, and also the user message. As you can see, this looks exactly the same as here. So we use the private method to actually implement that, but here we implement the base logic of that. So what we're going to do is we first try to get from the chat session that user ID. So we store all of the sessions here. And if we don't have a chat ID yet, we will create a new chat where we pass in the assistant ID. This returns a chat ID attribute as before, and we will set that chat ID as new key in this chat sessions dictionary. So we create a new chat here like this. And after creating the chat, we can create a new message. So we do it like before with the create message method from the assistant. And we pass the assistant ID, we pass the chat ID, and we pass in the text, which comes from the chat logic here as parameter. So we pass it here, create our new message, and then generate the response from the bot. And we will return the content and then the text attribute from the AI assistant. Keep in mind here that every message we created and every AI generated message will be stored in the state of the assistant. So we've got our stateful API, but we don't store these messages in the state of this backend, but we store it directly in the assistant in the cloud. Very important to keep that in mind. So let's continue and make the except statement. So if that does not work, we will just raise an error and return none. The next step is to create our chat with the fallback logic. So this class inherits from the chat logic class, And what we're going to do here is we create or override this chat method, which was not implemented before. And here we try to call the chat logic method with the assistant and the assistant ID 1 and pass in the user ID and the user message. If that does not work and we don't get a response, we will do that with the assistant ID 2. So we always have got a fallback if our first assistant does not work. We will also create another class without the fallback logic. So here we just implement the chat method and only do it with assistant ID 1. So assistant ID 2 will never be used. Okay, now we can create a factory pattern to actually use the chat with fallback or use the chat without fallback. And we do that if the use fallback variable is true, then we use with fallback, and otherwise we use the chat method without fallback. And this is set in our .env file. Okay, so now we've got our factory. So now let's create our endpoints. So the first endpoint is the root endpoint, and this returns a file response, and it returns the file from static index.html. So this is this file. So if we go to, let's say, localhost port 8000 and here to the root endpoint, we will see this index.html. Then we've got our chat endpoint, and this is where all of the logic happens. So we pass in a user ID. This will create or not create a new chat. We pass in the user message and we pass in the assistant. This will be passed with dependency injection. Okay, after that, we will call the chat logic factory method and create our new chat logic. Depends on if we have got this environment variable set to on or off or true or false. And after that, we will call the chat method, which we implemented in these two classes. So here we created it like this, and here we created it with a fallback. So we call that, pass in the assistant, pass in the user ID, and pass in the user message. This will return a response, and we will return the response to the user. Otherwise, if that does not work, we will raise an error. Okay, one last step, and that is to import ubicorn, and we will call the run method of ubicorn, and then we run our application on port 8000. So first make sure that you installed Fast API. You do it like this, pip install Fast API, and after that we are good to go. Now we only have to change the values in our .env file. So if you also use an entropic model, you also have to add the entropic API key inside that .env file. So this is what I'm gonna do now. Just paste it here, and the next step is to set the correct assistant IDs for assistant ID 1 and assistant ID 2. Just go back to the user interface, go to assistants, press F5 if necessary. So this assistant, my SDK assistant, was created with the SDK, and this one was created in the UI. So I'm gonna copy that one, and this will be assistant 2, and the OpenAI assistant will be assistant 1. So let's copy it there. And now we've got our assistant IDs, but let's make a little change to the prompt template. And let's say always answer in German. So this will show the difference a little bit better. So okay, now we are good to go. And now we can run Python app.py. Okay, so our app is now running on localhost port 8000, and we can navigate there in the browser. Okay, I'm on localhost port 8000 in the browser, and this is our very simple chat UI. So as default, we use the OpenAI assistant with the information about Bella Vista. So this was set in the collection. So we can just ask, when are the opening hours of Bella Vista? So now let's see if our assistant is able to answer that. And we can also see that the question is answered in German, as we just changed in our prompt, always answer in German. So this works. So, but now let's say we are very unhappy with this kind of behavior and we want to change to a different model with a different data source. This can be now easily done by just changing this simple environment variable. So we now want to use the entropic assistant. So we set this as assistant ID 1, restart our application. We go back to the browser, open a new chat window by pressing F5 and then ask again, when are the opening hours of Bella Vista? And now we should get this following answer. Unfortunately, I don't have enough context to determine the specific opening hours for a place called Bella Vista. So we also get this answer in English, and we get much more text. So this is the behavior of the Anthropic model instead of the OpenAI model. And this is my biggest pro of using TaskingAI. You can totally decouple your backend, different models, different data sources, easy to change and configure. This makes AI application development so much easier. Okay, we are now at the end of this video. My suggestion is that you give this awesome platform a try. For me, it's really a game changer, and the developer of TaskingAI plan to integrate even more awesome features. If you've got questions about TaskingAI and this platform, let me know them in the comments. Thank you very much for watching. See you, bye bye.